It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
So, good evening one and all. Hi Krishna. Good evening one and all. Welcome to Unacademy. So, as a part of our third module, number system, yesterday we have started finding out the last two digits of the given expression, right? Yesterday we have seen this. Now today we will see some very good techniques where you might have not seen till now, unless until if you have gone through very highest level examinations, right? In technical subjects you don't get these type of things. Hi Krishna. Now today we will see many techniques like Fermat-Little theorem, right? Euler-Thosian theorem, Wilson's theorem, modular arithmetic, right? All these techniques will help you to solve questions within 10 seconds, 20 seconds, right? Now, this is me, NLN Sharma, and everybody know about me, and these are my scores in different examinations. Now, when you use my code NLN10, apart from the 10% discount what you will get guidance of all these subjects from me. Is it only me? No, you will get the guidance of my entire group, right? From Ankit sir, Bhima sir, class finally to me. Now, you have seen in the video the difference between plus and iconic, right? The major boost in plus is you will be getting a personal coach who will be guiding you till the examination, right? Including your interview guidance. Now, how much you have to invest on this plus subscription? If it is Gate Plus, it is 1650 rupees per month, right? It's not even a bus pass in Bombay and Delhi, right? Now you will get IITians to teach at this cost. So when you use my code NLN10, you will get 10% discount, and after 10% discount, the price will be 27,225, and this is for 18 and 24 months. And if you are looking for iconic, yes, hi Sainath, good evening, and the price is 45,225 after using my code NLN10. Now, more than 3,000 members are following me on Unacademy, right? I am doing verbal capsule course for GATE 2022. Those who are interested can join this on Unacademy. Why I am doing verbal there? The interaction will be 10x more than this YouTube platform. So that's why I am doing verbal there, to be more connected with you. So download the Unacademy app, and this is the link to follow me. And from February 1st, new batches are going to start for GATE 22 and GATE 23, right? So do try to attend, and my ESC course will be starting from Feb 9th. So do try to attend those courses, and this is for electric EC wala, right? In the previous case it is electrical, now this is EC. Now what I say is, this code will be helpful to unlock free classes on Unacademy. You can unlock free classes on Unacademy. This code is useful to buy subscription, plus subscription on Unacademy, and this is the gateway to buy iconic subscription on Unacademy, right? And this code is applicable for all the courses on Unacademy. So I'll not waste your time. Let's come. Yesterday I have given you the basic of binomial theorem, and I have given how the Pascal triangle is framed, and the evaluations what we can do with Pascal triangle. I have given this in averages, mixtures, eligations, in compound interest. Now I have started how to calculate finding out the last two digits of the given expression. See here, totally 4 rules. I have done rule 1, rule 2 numbers ending with 5, rule 3 numbers ending with 3 comma 7 comma 9. So I have started rule 4, then I have to explain only one rule. I will explain that one rule and then we'll go back to modular arithmetic, right? So what is rule 4? The last rule. Only 4 rules are there. I have given you 3 rules yesterday. Now today we will see the rule number 4. I gave just the glimpse of rule 4. I don't know how many of you remembered this. Numbers ending with 2 comma 4 comma 6 comma 8. Numbers ending with 2 comma 4 comma 6 comma 8. Right, now see here what I said. Convert the given question expression. Convert given question expression. Now you can solve within 10 seconds, but don't worry. Convert given question expression to 2 to the power of 10 whole to the power of n. I'll write down in one more ring. 2 to the power of 10 whole to the power of n. Now if you can convert your given question expression into this format. Now if your n is even number, then your last 2 digits are 76. If your n is odd number, then your last 2 digits are 24. That's it. Right, now see here, I'll start with some examples. So we will increase the level of examples, then we can solve it. Now observe the question given there. Now my first question is 16 to the power of 1000. 16 to the power of 1000. Now what are the last 2 digits for this expression? Can anybody say in the comment section box? Now see here, 16 is exactly in the format of 2 powers. Can I write down this 16 as 2 to the power of 4 whole to the power of 1000? So can I write down the same question expression as like this, 2 to the power of 10 whole to the power of 400? Is it okay for you? Everything will be retained to 4000 only. And automatically my question is done. Observe here, 2 to the power of 10 whole to the power of n, and your n is even number. If your n is even number, last 2 digits will be how much? Will it be 76? Yes, the answer is 76. That's it. So you don't need to do anything here. Clear? So every question can be solved within 10 seconds using this technique. Right, very good, very good. Let's see one more example. Now if this is the question asked, 8 to the power of 1000. 8 to the power of 1000. Now let me know the answer there. 8 can be written as 2 cube and whole to the power of 1000. Now I can write down the same question expression as like this, 2 to the power of 10 whole to the power of 300. Now what is the answer there? Is it again your n value is even number and your last 2 digits are 76? Will you accept this? Yes. And this easy questions everybody can solve it, right? Without my help you can easily solve once you know the rule perfectly. Let's see some next level question. If you are asked to find out for 2 marks question, then it takes some trickish way. Now if this is my question there, 48 to the power of 199. Now let me know what is your answer there. Now can you write down? Now see here, 48 is not at all in the format of 2 powers. You cannot directly write it. So the 48 can be written as like this, 16 into 3 is 48. This is the highest possible way. So can I write down this 48 as, can anybody say in the comment section box whether I am right or wrong? 2 to the power of 4 into 3 whole to the power of 199. Can I write down the given question expression like this? Please let me know, yes or no. Yes, perfectly I can write down like this. Now see here, I will convert the same question expression like this, 2 to the power of 4 whole to the power of 199. Yes, 2 to the power of 4 whole to the power of 199 into 3 to the power of 199. Yes, I can write down the same question expression like this, Now see here, for my convenience, what I will do is I will calculate the left hand value first and right hand value next. Now, right, it is in the format of a to the power of m whole to the power of n. So I can directly write down like this: 4 9s are 36, 4 9s are 36, 39. So it will be 2 to the power of 796. Sir, why you are doing all these things? My aim is to convert the given question into this format. This is my aim. So to achieve this aim, I am writing down like this. Now can I write down 2 to the power of 796 as 2 to the power of 790 into 2 to the power of 6? Is it okay for you? And can I write down this as 2 to the power of 10 whole to the power of 79? Is it okay for you? Into 2 to the power of 6 is how much? 64, that everybody know. Now closely observe there, 2 to the power of 10 whole to the power of n, and your n value is odd number. So your last two digits are 24. Am I right or wrong? So finally this side you will get it as 24 into 64. So I'll keep it aside. Right? I'll calculate this later. Let's keep it aside. Now come to the right hand side. Everybody know how to calculate 3. I have given the rules yesterday. Numbers ending with 3 comma 7 comma 9. What I have said that the unit digit has to be converted to 1. How to convert to 1? Raise the given number to the power of 4. 3 if you raise to the power of 4, automatically the unit digit will become 1. Yes, I can write down like this. Yes, 3 to the power of 4. Very good, excellent. So 3 to the power of 4 whole to the power of 4, 49. Again 4 9s are 36. Leftover value is 3 cube. Everybody know. 3 to the power of 4 is how much? 81. 81 whole to the power of 49 into 3 cube is 27. Now everybody know rule 1. How to convert this one? Please let me know. Yesterday we have seen this. Your unit digit will always be 1. 8 9s are 56. Now this is 61. 61 into 27. Am I right or wrong? Yes. Sir, I don't have calci and I am very lazy in calculating all those things. So how shall I do it? Now see here, this part. I'll write down this part in the next slide. 24 into 64 can be written as 20 plus 4 into 64. And you need only the last two digits. Now you don't need to worry about the remaining things. Ab dekho idhar. So 2 4s are 8. 2 6s are 12. 128. 0 is nothing but 64 into 2. How much will be 4? 4 4s are 16. Is it 256? Yes. Am I right? Yes, 256. Now I need only the last two digits. My last two digits are 36 here. Done. Now come to the next one. This one 61 into 27. Again sir, I am very lethargic to calculate this. I will write down 27 as 30 minus 3. And that is very easy way to calculate for me. So 3 1s are 3, 3 6s are 18, 1830 minus 183. Now how much will be the answer there? Can anybody say? 7. Am I right or wrong? 18303. Yes, 183. Now what is the answer there? Is it 57? Yes. Now finally your answer will be 36 into 57. And I am very lazy to calculate this also. I will write down like this: 36 into 60 minus 3. Right? I can write down like this. Yes, perfectly. 6 6 are 36. 6 3s are 18. 2160. Automatically 3 6 are 18. 3 3s are 9. Now what is the answer there? Are we missing down anything there? Are we missing down anything there? This is 27, right? 30 minus 3. Are we doing any calculative error there? Please let me know once. So see here, this is the thing, right? Any calculative error? Please let me know. This is 8 9s are Ariyar. Abdullah, your Sheikh Abdullah, right? 8 9s are how much? 72. So the last two digits will be how much? 21. So 21 into 27, last two digits will be how much? 67. So this is what we have done a mistake there. Now 36, at last finally 36 into 67. This is the final number left over. So 36 into 70 minus 3. I can write down like this, will be 67. 7 6 are 42. 7 3s are 21. 2520. minus 3 6 are 18 108. So my last two digits will be how much? 12, and this is your answer. That's it. A little bit higher level, which was asked in the previous examination only. So that's why I took this question. So let's see one more example, then I will completely move on to modular arithmetic. Now closely observe there. Sir, you have done unit digit, you have done double digits, 48 also. When we are given with very large number, then what will we do? So if this is the question asked, 2018 whole to the power of 2018 whole to the power of 120. Now let me know what will you do here. Arey yaar, if you convert this 2018 into 2 to the power of 10 format, it takes at least 3 to 4 minutes. Why to focus on the entire number? Your question is to find out the last two digits of the given expression. Am I right or wrong? So focus only on the last two digits. So I will convert the given question as 18 to the power of 120. 18 to the power of 120. Yes, now see here, as I said, when it is given 8, now what shall you have to convert them into 2 to the power of 10 format. How to convert this? This can be written as 2 into 3 square, 18 can be written as, am I right or wrong? 9 2s are 18. So can I write down the same question as 2 into 3 square whole to the power of 120? Yes, I can write down this. Now I can write down the same question as 2 to the power of 10 whole to the power of 12 into, I can write down this as 3 to the power of 240. Will you accept this? Yes, perfectly. Now see here, I got the answer very easily. Now last two digits of this expression is what? 2 to the power of 10 whole to the power of 12. 12 is even number. So my last two digits will be 76. That's it. And this everybody know how to convert this. 3 to the power of 4 whole to the power of 80. Is it 80? 60. 60. Now automatically what is the last digit there? 81 whole to the power of 60. Now last two digits for this expression is how much? 1 0. So 76 into 01, finally your answer will be 76. Now this is the answer. So when you are given with large numbers, focus on only on the last two digits, as my question is to find out last two digits of the given expression. Why to focus on the entire numbers there and wasting my time there? Is it clear? Now, yes. Now let us go to today's topic, and today's topic is very, very important. So ask your friends to join. I'll make sure that you will understand each and every point very perfectly. Now, today's topic is about modular arithmetic. What is this modular arithmetic? Most of you have seen modular arithmetic, but in our advanced mathematics there are two other types of arithmetic also: crypt arithmetic and modular arithmetic. So I will be today explaining about modular arithmetic, and later on classes I will explain you crypt arithmetic. Right. Now I will write down the theorem first exactly, and then let us decide about this later. Now a to the power of n is exactly congruent to, or otherwise directly I'll write down a only, right? A is congruent to b. A is congruent to b when it is divided with modulus of c. Now this is the theorem. Sir, what is this theorem and what you are saying, right? Let's little bit focus on this. Right. Now when you closely observe there, I have written it it is not equal to ma. I have written it as 3 stripes. Now this is called congruency. Congruency, right? I'll write down the word there. So what I am saying that A and B are congruent, it seems, when they are multiplied with C, it seems. Means congruency, matlab, what is the exact meaning there? Can anybody say in the comment section box? The exact meaning of modular arithmetic is when you divide A by C, you will get some remainder. When you divide B by C, you will get the same remainder. So if A and B, if they are multiplied by C, if you are getting same remainder, then automatically A and B are congruent. Now I'll give with an example there. Now I'll take an example like this. 15 15 is congruent to 7 when it is divided with modulus of 4. Is it right? Please let me know. When you divide 15 by 4, what is the remainder there? Is it 3? 4 3s are 12, 3 will be the remainder. When you divide 7 by 4, 4 1s are 4, remainder will be 3. Now see here, 15 and 7 are congruent when they are divided with modulus of 4. And you might get one more doubt. Sir, I have divided 15 by 4, that 15 is exhausted now. Why? Where that second 4 have got you for 7? Where did you got that second 4 for dividing 7? You might have got that doubt. Yes, see here, that is what the modulus 4 means. Modulus means you can use the divisor infinite number of times in order to find out the remainder. Divisor can be used infinite number of times. So you might have seen this in this mathematics very frequently, infinite number of times. I'll write down like this. Right. So I'll give an explanation for this also. So that's why you can have a better clarity regarding this. Now what is this? So this modular arithmetic also follows one cyclicity pattern now. So I'll show that cyclicity pattern there. Now observe there. You said that when 15 is divided by 4, the remainder is 3. I'll write down the remainder is ready. Now see here, next one. When you divide 16, the remainder will be 0. I'll write down the remainders here. When you divide 17 by 4, what will be the remainder there? 1. If you divide 18 by 4, remainder will be 2. If you divide 19 divided by 4, again remainder will be 3. 20, 0. Now when you closely observe there, the pattern of movement of remainders is the same way, right? 3 0 1 2 and again 3 0 1 2 pattern will be moved. Now this is called your modular arithmetic cyclicity pattern. So now in this cyclicity you are speaking about the remainders here. Now this is the exact concept. Now with this concept we will solve each and every question, right? So coming to the next topic, right? This is the basic of modular arithmetic. Why there are no students today? What happened? I think, you are too intelligent here. You don't need any classes, right? Right. Let's come to the topic there. Now, today, let us see one concept in modular arithmetic which is called Fermat-Little theorem. Fermat-Little theorem. What is this Fermat-Little theorem? So those who are in EC from final years can easily understand these theorems. You might have seen a subject called cryptography. In this, cryptography is nothing but decoding the numbers. How to decode the numbers. So first of all, what this theorem is saying there. Now if you can write down the given, this is the theorem. A to the power of p minus 1 will be incongruent to 1 when it is divided with modulus of p. Now this is the theorem there. Now exactly in modular arithmetic format only. Now when you divide a to the power of p minus 1 by p, you have to get remainder 1. When you divide 1 by p, automatically the remainder will be 1. So both these two are in congruency, it seems. Right. And one more thing, what is this p? This p is nothing but prime number. So this Fermat-Little theorem will be used to find out when divisors are prime numbers only. Okay. Now see here, if you don't know this theorem, automatically it takes very huge time to calculate the answers. I will show the normal textbook approach and then I will come to this Fermat-Little theorem. You can use whatever you like and whatever which is comfortable to you. Let's come with an example. Now this is the question asked. This is the question asked. 1, 2, 3, 4 whole to the power of 1, 2, 3, 4 when it is divided by 5, what is the remainder there? This is the question asked. Can anybody solve it? Now automatically most of the guys will solve with binomial theorem, I know that. So please let me know your answers there in the comment section box. So can I do like this? First of all, in your textbook, what they say is, convert the numerator into binomial theorem format. Yes, I will convert this. Sir, how to break down this given numerator into binomial theorem format? That depends upon your pure logic. Nobody can help you on this. So as the divisor is 5, so if a number has to be divisible by 5, the number has to end with 0 or 5. Am I right or wrong? So I will break the number into that format. So I will break down the number as 1230 plus 4 whole to the power of 1234. Yes, I have break down the numerator into that format. Now can anybody say the first term of binomial theorem? Yes, I will write down the first term. देखो इधर 1234 C 0 into 1230 whole to the power of 1234 into 4 to the power of 0. Now what is the next term? 1234 C1 into 1230 whole to the power of 1233 into 4 to the power of 1. So I'll write down the last term slowly, right? I'll write down the last term there. 1234 C1234 into 1230 whole to the power of 1 into 4 to the power of 1234. Will you accept this? Yes. This is the binomial theorem. As you have break down this into things, can I write down the format like this? Divided by 5, divided by 5, divided by 5. Yes, I can write down like this. The same question expression I have written like this. Will you accept this? Now closely observe there. 1234 C0 is 1. So 4 to the power of 0 is 1. So automatically if a number is ending with 0, it is divisible by 5. So if 1230 is divisible by 5, then the entire number, so this entire part is divisible and you will get a remainder of 0 here. Will you accept this? Yes. And the same thing will happen there. So if you multiply this number, the number will end with 0. If a number is ending with 0, yes, it is divisible by 5. Yes, the first two terms are divisible. In this way, every term is divisible by 5. Come to the last one. Last one, 1234, see 1234 is 1. 1230 whole to the power of 0 is 1. This is 0 mark. And see here, remaining thing is 4 to the power of 1234. Arey yaar, this 4 is not divisible by 5. You will get a remainder of 5. Am I right or wrong? So how to do? First of all, leave this headache. This is the thing that you have to do when you follow the exact textbook approach. And here we don't need any textbook approach. We will solve the same question with Fermat-Little theorem. They go there. The same example. 1234 whole to the power of 1234 divided by 5. Now closely observe there. I'll write down. Now 5 is a prime number or not? Please let me know. Yes, 5 is a prime number. Now p minus 1 value is how much? Is it 4? Yes, perfectly. P minus 1 value is 4. Now if you can write down the given question expression, like I am writing down the same question expression in Fermat-Little theorem format. 1234 whole to the power of 4 is incongruence to 1 when it is divided with modulus of 5. Yes, perfectly done. Now, but the given question expression contains a power of 1, 2, 3, 4. So how shall I write down this? So see here, I will write down the given question expression like this. 1, 2, 3, 4 whole to the power of 4. Now, but the exact number is 1, 2, 3, 4. How can you write down this? Break down the numerator there. Please let me know the numerator format there. A to the power of m whole to the power of n. 4 3s are 12, 4 0s are, 4 8s are 32. Leftover part is how much? 1, 2, 3, 4 whole to the power of 4 are 2. Now see here, I have break down the numerator into two parts. I have break down the numerator into two parts. As it is modulus of 5, I can use divisor innumerable number of times in order to find out the answer. Innumerable number of times. What I will do is, see here, as I have divided the numerator into two parts, I will divide the two parts separately by 5. As it is modulus of 5 that I have given in the expression itself. Now observe here, you said that what I'll write down here. You said that 1, 2, 3, 4 whole to the power of 4, when it is divisible by 5, the remainder will be how much? 1. This is what according to the theorem that you have written there. Now closely observe there, how many 1, 2, 3, 4 whole to the power of 4s are there? 308 are there. You can use 308 times in the 5 in the denominator. For every expression the answer is remainder is 1 only. So final case the answer will be 1 only in this case. Done, over. Half of the part is over. Now come to here. How many 1, 2, 3, 4s are there? 2, 1, 2, 3, 4s are there. I'll write down like this for my convenience. As it is the first question, I'll write down like this. So can I break down like this? Yes, I can break down like this. Now what is the remainder for this? Can anybody say? Is it 4? Yes, the remainder is 4. Again here also 4. Yes, it is 4. 4 into 4 is how much? 16. So again 16 is also divisible by 5. So by this you might have got a clarity, right? How many times you have to use 5? Unless you will be finding out a number which is not divisible by divisor, that is the remainder. Remainder, exact meaning of remainder is that only, na? So you have to find out a number which is at last finally not divisible by divisor. 16 divided by 5, remainder is how much? Is it 1? So in this case the remainder will be 1. So 1 into 1, your final answer will be 1. Now this is your answer. Now you will get the same answer here also, right? You can do in your, you can do this thing at your home. So I'll give you more number of examples. You don't worry about that. Now see, let us see one more example. Now as it is very clear now, I will make sure that you will be solving each and every question right now in 30 seconds. Now this is my question. 1, 2, 3, 4 whole to the power of 1, 2, 3, 4. Now Krishna, give me any number of your choice. I'll solve with your number. Divided by 7. Is 7 a prime number? Yes, 7 is a prime number. So my p minus 1 value will be 6. So write down the given question expression in this format. 1, 2, 3, 4 whole to the power of 6 whole to the power of, it is exactly 1, 2, 3, 4 there. So 6 2s are 10, 6 zeros are 6 5s are 30. How much is left over? 1, 2, 3, 4 whole to the power of 4 is left over. Now see, I have divided the numerator into two parts. So I will divide each part separately by 7, as it is modulus of 7 by theorem. Now you can closely observe there, the left hand part is exactly in the Fermat-Little theorem format and the remainder is 1. 1, 2, 3, 4 whole to the power of 6 is congruent to 1 when it is divided with modulus of 7. This everybody know. I think I am clear. Yes. Now come to this one. Divide 1, 1, 2, 3, 4 divided by 7, and what will be the remainder? Can anybody say in the comment section box? Divided 7 ones are 7, 53. Again 7 7s are 49, 44. 2 will be the remainder. So how many 1, 2, 3, 4s are there? 4. 2 into 2 into 2 into 2, 16. 16 divided by 7. Remainder will be how much? 2. So finally your answer will be 2. Yes. Krishna, give me one number. I will solve with your number there. Das, I think Satvik is there in the class. Sainath. Give me one number, whatever, your choice, right? As yesterday likewise. Give your own number, I'll solve the question with that number. Anybody of your choice. Right. So I will be asking the question which was asked in a previous GATE examination only. So this was the question asked in 2015. The question asked was 13 to the power of 56 whole to the power of 5. What is the remainder? This is the question asked. 13 to the power of 56. What is the remainder asked? This is what the question asked. So you might get a doubt, sir. P is 5. Now how much will be P minus 1? P minus 1 will be 4. Yes, perfectly done. Now closely observe there. Can I write down the given question expression like this? 13 to the power of 4 whole to the power of 14. Nothing. Leftover part is nothing. Divided by 5. Then what is the remainder there? It is exactly in the Fermat-Little theorem format, and your reminder is 1. There is no need to calculate anything. That's it. 10 seconds, 2 marks. Done. Now, I want you to know the conditions there. Right? And observe here, A comma P must be co-prime numbers. Why they must be co-prime numbers? Can anybody say in the comment section box why I said that A comma P must be co-prime numbers? Why A comma P must be co-prime numbers? Are co-primes means there must be no common factor between the numbers. Am I right or wrong? If there is a common factor, automatically A and P will be divisible. If they are divisible, automatically why to use this theorem? If they are divisible, what is the remainder there? 0 is the remainder. Then why to suffer all those things and solve those? So the condition for this theorem is A comma P must be co-prime numbers. Right? Now this is what decoding the numbers. Yes. Now this theorem is applicable only when the divisor is prime number. This is what I have written there. You might ask me one more question. Sir, if it is not prime number, then what shall we do? Yes. There is one more theorem. That's it. There is one more. You can use any question with this and you can solve it. There is one more theorem called Euler-Thosian theorem. Euler-Thosian theorem. Now, what is this Euler-Thosian theorem? Now, before going to this Euler-Thosian theorem, I want you guys to know some more basics in number system. Let's solve that one and then we'll go back to the question there. Right. In your primary classes, you will be asked this. Find the number of factors for 100. How will you find out number of factors for 100? First of all, what is factors? Factors means the number which can divide 100 exactly. Am I right or wrong? The numbers which can divide 100 exactly. So you call these factors as divisors. You call these factors as solutions or roots in the quadratic equations. Am I right or wrong? Whatever might be, the same answer is applicable. Now start from least number. Now I can write down 1. 100 is divisible by 1. 100 is divisible by 2. 100 is divisible by 4. Next one is 5. Next one is 10. Anybody in the comment section box? Next one is 20. Next one is 25. Next one is 50. And the final one is 100. Am I right or wrong? So totally how many number of terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 are there. So 100 is an easy number. So you have written it very easily. Now if it is a very huge number, counting down these numbers will be a very hectic task and literally you will feel suffering there. So what shall we do is, we will find out a common method for this. Now if you are given with a number called n, and if you are asked to find out number of factors for this. So first write down the number in the format of a to the power of p into b to the power of q into c to the power of r, so on. So up to the number what you have. And your a comma b comma c are prime numbers. A comma b comma c are prime numbers. Means you have to write down the given number into prime factors. Now the first case is how to find out number of factors. Can anybody say in the comment section box? That's an easy formula. Since your primary classes you might have seen this. How to find out number of factors? P plus 1 into Q plus 1 into R plus 1, so on. Am I right or wrong? Up to the numbers what you have. Now see here, I will find out the same answer with this one. Now write down 100 into prime factors. I can write down 100 as 2 square into 5 square. Yes, I have written this. Now what is P? Now there are only two numbers, A and B. Now P value is 2 and Q value is 2. So 2 plus 1 into 2 plus 1. So my final answer is how much? Is it 9? Yes, I got the same answer. Count this, again the same number, 9 I have got it. So if you are given with very huge numbers, this formula will easily helpful. It will be easily helpful for you to solve the questions. I am clear regarding this? Yes. Shall we go on to the next one? Yes. Are yaar dekho. Now add these factors and let me know the answer there. Add these factors. 1 2 4 5, right? 1 plus 2 3, 3 plus 4 7, 7 plus 5 12. So let us keep it 12. 30 plus 150 180, 205. So totally it will be 217. Am I right or wrong? One check there. 150, 175, 180, 200, 210, 270. Yes, perfectly 270. As it is very easy number, for this easy number also I have done twice. So how to find, what is the formula to find out sum of factors? So I'll write down here. I'll write down in separating. So to find out sum of factors, this is the thing. Sum of factors is nothing but equal to, now see here, a to the power of 0 plus a to the power of 1, so on up to the whatever the a has the highest power, into b to the power of 0 plus b to the power of 1, so on up to highest one. So on, right? If you can write down like this, then now please let me know the answer for this. As 2 square na, so 2 to the power of 0 is 1, 2 to the power of 1 is 1, 2 square is 4, up to 2 square. Next one 5, 5 to the power of 1 is 5, 5 to the power of 0 is 1, 5 to the power of 1 is 5, 5 square is 25. Am I right or wrong? Now closely observe there, 4 plus 2 is 6, 6 plus 1 is 7. Now 7 into 31 is how much? Will you get the same answer 217? Yes, you will get the same answer 217. Now this is the thing that you have to know there. If you can know this, then fatafat you can easily solve this. And the last one, finding out number of co-primes. I'll write down in one more ink, right? Black ink. How to find out number of co-primes. Already I have said the definition of co-primes in many classes. I think I have no need to repeat the same thing again, right? Number of co-primes is represented as psi of n. Now psi of n is nothing but equal to n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c, so on up to the number what it has. Now you can merely substitute the thing there and you can find out the answer there for number of co-primes. Now this is the thing that is a prerequisite that you have to know for Euler-Thosian theorem, and also for different solving questions. Tomorrow I will get more number of questions to solve, then we can make it this very easily. Here we have learnt all those things. In what way this is helpful for Euler-Thosian theorem? Let's check there in the next slide. So what Euler-Thosian theorem says is, the given question expression will be in this format: a to the power of psi of n, which is congruent to 1, and when it is divided with modulus of n. Now what is n there? Can anybody say in the comment section box? This n is nothing but composite number. This n is nothing but composite number. As I said, prime numbers is for Fermat-Little theorem, composite numbers is for Euler-Thosian theorem. Done. And again here also your a comma n must be co-prime numbers. Otherwise, if they are exactly divisible, why to have this theorem, right? There is no need to have this theorem. The remainder will be 0 now if they are divisible. Yes. Now psi of n is nothing but number of co-primes. I will write down here in separating so that you can understand this number of co-primes. I think I am clear regarding this. Yes. Now let's solve some questions, then you can get better clarity there. So this is the question that I want to take. Now 123 whole to the power of 123, when it is divisible by 8, now let me know the answer there, or 4, whatever you wish. Now how will you answer this? Now see here, first of all, n is 8, you have to find out psi of 8 value. How to find out psi of 8 value? First of all, 8 can be written as 2 cube. Am I right or wrong? There is only 1. So which is nothing but n into 8 into 1 minus 1 by a. So a value is how much? 2 only. So finally psi of 8 value is 4. So psi of 8, so you have to write down the given question expression into this format. 123 whole to the power of 4, whole to the power of 4, whole to the power of, as psi of n is 4, psi of 8 is 4. Now how much is this? 4 3s are 12, 30. How much is left over? 123 whole cube is left over. Am I right or wrong? Now the left hand part I will divide it by 8 and the right hand part I will divide it by 8. Now what is the answer there? Can anybody say? For the left hand part the answer will be 1, as it is exactly in Euler-Thomson theorem format. Come to the right hand one. How will you solve this, right? If 123 is divisible by 8, what will be the remainder, ma? Can anybody say in the comment section box? 8 ones are 8, 43, and the remainder will be 3. How many 1, 2, 3s are there? 3 are there. 3 into 3 into 3. How much is 27? 27 divided by 8, remainder will be how much? Will it be 3? Yes. And your final answer is 3. I think I am clear regarding this. Yes. So you got the answer there. Now see here, 8. All the numbers has to be composite numbers in Euler-Thomson theorem. Now you can take any example regarding that where you can solve the questions fatafat. Right? Shall we solve one more question? We'll solve one more question, right? So what shall I write? 4, 5, 89, 589. Yes, 589 whole to the power of 120 when it is divisible by 6. Now please let me know the answer for this. Can anybody in the comment section box? 589 divided by 6. Now see, these type of topics are little bit on higher note, but you have to solve this, right? In the exam, if you want to get to more than 2 marks, this is the way, right? Because I cannot make you entertaining every day. Any answers? Now see here, everybody know psi of 6 is composite number. Now how can you write down 6 as prime factors? 6 can be written as 2 into 3. Will you accept this? Yes. And I can write down 6 into 1 minus 1 by 2. A is 2 and B is 3 into 1 minus 1 by 3. At last, can anybody say the final value there? Yes, I can write down like this, 2, 3. So 6 into 1 by 2 into 6, 2 by 3. So at last, finally, psi of 6 is 2. So I can write down the same question as 589 whole to the power of whole square. So whole to the power of 120 is nothing but 60 divided by 6. Now automatically see here, it is exactly in the format of Euler-Thomson theorem. So your remainder will be 1. Now in the previous case, how much remainder did you got? Is it 3? Yes, perfectly 3. So I think it is clear regarding this. Now let's see one more question, then we will wind up the things. Can anyone solve this one? 123 whole to the power of 123 when it is divided with 4. Please let me know the answer there. So see here, 4, psi of 4 can be written as, psi of 4 can be written as, can anybody in the comment section box? So 4 can be written as 4 into 1 minus 1 by 2. 2 square na? Yes. So finally the answer will be 2. So I can write down the same question as 123 whole square into 123 whole square whole to the power of 60 into 123 3. Am I right or wrong? Divided by 4 divided by 4. Now what is the remainder for this? Is it 1 by Fermat, by Euler-Thorsen theorem? Yes. What is the remainder for this? If you divide 123 by 4, the remainder will be 3. Am I right or wrong? So how many 3s are there? 27. 27 divided by 3, again the remainder will be 3. So finally your remainder will be how much? Is it 3? Yes, it is 3. Done. So will you solve one more question so that we will end it? Right now, this is the question asked in one examination mark. 4 2's whole to the power of 4 5's divided by 7. Now this is the question asked in one examination. So can anybody try? So 7 is prime number. I will be giving you 2 minutes for this. Try this question. By using Fermat-Little theorem, you can easily solve it. Try this. Krishna, answer. Waiting for the answer. The last one. This is the last one. I'll end this. Huge time to solve. Zero is the remainder. How can be 0 is the remainder, Praneeth? First of all, 222, 7 3s are 21, 12. 7 3s are 21, 12, 752. Are you here? How can 0 be remainder? 4 2's divided by 7 is not divisible, na? Now I am getting a doubt here. No, yaar. Not 0. Not 0. Dekho, see here, A and P are not co-primes, right? How can it be 0? Now, dekho, P value, this is prime number. Mistake. Okay, fine, no issues, right? Your P minus 1 value has to be 6. So, the question has to be written in the format of 4 2's whole to the power of 6 whole to the power of 6 9's are 54, 15, 6 2's are 12, 35, 6 5's are 30. So the remainder part is 4 2's whole to the power of 5. Am I right or wrong? So I have divided the numerator into 2 parts. So I will divide the 2 parts by 7 separately. Yes, I am dividing it separately. Now closely observe there, it is exactly in the Fermat-Little theorem format and your remainder will be 1. Come to the next hand part. Divide 4 2's and let me know the answer there for this. Divided by 7. 7 3's are 21. 12. 7 1's are 752. 7 7's are 49. 3. So how many 3's are there? 5 3's are there. So it is 243. 243 divided by 7. What will be the remainder there? 7 3's are 21. 333. 5 will be the remainder. So your final answer is 1 into 5. The remainder will be 5. I think I am clear regarding this. Now what I say is you can solve each and every question using this logic very easily and very fastly. So trust me in this. Shall we do one more question or shall we end it? So tomorrow we will be going to see Wilson's theorem. So how to solve the question with factorial numbers. So Wilson's theorem, tomorrow I will be explaining you Wilson's theorem. I will be explaining you Chinese remainder theorem. I will be explaining you negative remainder theorem. Now these questions can be solved with Chinese remainder theorem, negative remainder theorem, right? And I will be explaining you Muller's concept to solve the questions, right? Negative remainder. Right, tomorrow I will be explaining all these concepts, right? So tomorrow we will be ending with this one part of number system. Then we will see the next part in February. Right? So do try to watch these videos. those who are going for placement training, right, these type of things will be very, very helpful for them, right? For sure. Right? Shall we do one more question or not? Right. So I will be forwarding the notes to this Telegram group. Please join this Telegram group, right? Not only this, I will be forwarding to all the Telegram groups. All the Telegram group links are in the description. You can join whatever Telegram group you wish. Now see here, as everybody know, Ravindra Babu Rawala sir have joined Unacademy and he is taking classes on C++ on this Unacademy Com Science channel and also in his channel. So those who are looking for placement technical training, so he's the best in India, right? Go through this channel and watch his videos. And I have done complete ESE prelims videos, right, from ecology, ethics, project management, everything, right? So in Creatrix and also in Mechanical channel. So go through those channels and watch those videos for your examination preparation. And those who are expecting geography, history and all those non-tech syllabus, right, this is the channel to look after. Anurag Singh sir is dealing the best way, right? And Deco SSC, JEE, Kemendra sir and all were dealing in the best way there. And at last what I say is, so if you want to unlock free classes on Unacademy, yes, you can use this code. If you want to buy plus subscription, yes, you can use this code. If you want to buy Iconic, yes, you can use this code, right? So tomorrow 12:30 I will be conducting a verbal workshop for 2001 GATE students. So even though if you don't know anything, you can attend that class. Verbal workshop at 12:30 noon sharp. So do try to attend. Tomorrow we'll be having one grand test also. Let's see how many can crack those things. Right? And this is for plus subscription. The fee will be 27,225. And for Iconic, it will be 45,225. Yeah. Thank you, and let's meet tomorrow sharp 6:15 p.m. And Saturday for GATE 2021, I will be conducting a marathon of all the questions together. So do try to attend it. A marathon session, right? So please like the video, share this video, right, and subscribe to the channel so that you can get more initiatives, more things will be given for you, right? Thank you and good night.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
And battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.